So the next part, maybe a more interesting part for the people here, and most people here are sysadmins, I guess, interested in helping out their users. So how do you make EESSI available to your users? So what's actually needed? What kind of effort do you have to do? There's a hands-on part to this as well. We plan that for after the coffee break. There's a bit of preparation there. We want to give you a VM with sudo right, so not the one in cluster in the cloud. There you're a normal user. We can give you a dedicated VM pretty easily. We have some scripts to easily set that up, again, tied to your GitHub account. If you're interested in playing with that, drop it in Slack in the community meeting channel, because Terje, who's in Norway, he's the expert in all this scripting and firing up these VMs. So we'll need his help anyway to fire it up. I can do it as well, but it's better if you post it there, and then maybe Terje can help out with setting that up. So how can you get access to EESSI, or how can you make sure that your users can access EESSI? There's two ways that we often promote. There's actually a third way, but I haven't tried that myself, even though I've been told multiple times to try it. I'm not sure if others have tried it. Maybe that's something for the hands-on, the hackathon this afternoon, if you want to play with it. We'll give you a VM and you can let us know whether it works out. That's option 3, which is not on this slide, but I have a separate slide on that. So the first one, and that's for now the only one we have in our documentation, is to use a container. So you can run the container image via Singularity. That's very easy. The documentation gives you all the steps, and I'll explain these in the slides as well. The container image only has a bare OS. I think it's CentOS 7, which is dead, but fine. The container is there and it works. And all the container really has is CVMFS inside of it. Nothing else. There's no software, there's no LMOD, there's no easy build, there's no TensorFlow. None of that is there. It basically gives you everything that you need to access EESSI if you only have Singularity installed. So any researcher can do this. They don't need any special rights. This is actually something I think you can try from cluster in the cloud as well, since you have a regular account that I'm not sure if Singularity is there. But so anywhere where Singularity is available, you can try this. This is good enough to play around, definitely single node. That should work fine. You can make this work multi-node as well. That's what Alan did in Jülich for the performance study we did with GROMACS for the EESSI paper. So a big multi-node run with GROMACS on Yusuf, the system in Jülich, without having CVMFS installed on the system at all. So it's just using that container. And a little trick in CVMFS called an alien cache, where you basically pre-download what you need, you put it on a shared file system, and you then let CVMFS talk to that rather than letting it pull down stuff. So that works. The other option, the more interesting one, if you're looking into the production install of EESSI, making it available in our cluster, is a native CVMFS installation, configuring that and making sure you can access that. It only uses a local client cache, but again, if you want to be a good citizen and not hammer our Stratum ones, you should either set up a proxy, so like a cache within your network, that's a partial cache, or a full mirror, your own private Stratum one that has a full copy of everything. So you can basically talk to that rather than to the public Stratum ones and hammering our network. Okay, so start with option 1. Our client container, which we puzzled together ourselves. It's available in the GitHub container registry, so it's a pretty easy URL you can use. It says Docker. I don't think it actually works with Docker to get access to EESSI because, or at least I haven't figured out how to do that. But it does work easily with Singularity, probably also with Aptainer, so the fork of Singularity or the rebranding of Singularity, which I haven't tried, but it should work because it's supposed to be compatible. CVMFS and the EESSI configuration is included in the container itself. You don't need CVMFS at all on the host. If it's there, it's fine. If not, it should still work fine. It uses a couple of bind options for the Singularity command. So CVMFS expects to have space in /var lib CVMFS and var run CVMFS. That's where it puts the local client cache and a bunch of things to figure out what has been downloaded or what's still going on. So it needs write access to that. So you have to bind mount directories to these locations in the container. And then the magic option, which makes sure that the CVMFS repository can be mounted in the container, even though CVMFS is in the container itself. That's with the fuse mount option. So basically does the mount as you start up the container. This is well documented, so all the commands are in our documentation. You can copy paste them, and it provides some brief explanation what's going on. We also have a script for this. So in the EESSI demo repository, in the script subdirectory, there's a start Singularity EESSI pilot script, which has all those commands. You can just run that script, and it should work, as long as you have Singularity available. Now, this is basically what the script does. It's fairly trivial. The important thing is that a small assumption here is that you have a /temp, which is big enough. If it's not big enough, use something else. So yeah, maybe try it with /temp. If it doesn't work with /temp, you may have to play with this a bit. So what it does, it creates the directories which we're going to bind mount into the container. So temp varrun cvmfs is mounted bound to varrun cvmfs in the container. Same for lib. We also make sure we have an empty home directory here, just a clean environment to play around in and to mess stuff up if you want to. And then the magic here is this long string, which we give to the fuse mount option, which basically says we're going to use cvmfs to mount this cvmfs repository into this path. Okay, what's actually going on in the background, don't ask me, but it works. And then the last part here, this is the actual Singularity command. We're going to start a shell in the container, and we're going to use our client container, which is available through the GitHub container registry. Right. So let's see if I still have a node. I was testing that this morning, so I should have a node still running. If I can remember where it is. Yeah, it's this one. So this is, you'll have to trust me, but this is basically an empty VM. It's a RHEL 8 VM, which we just started this morning. I don't think it has much of anything. It certainly doesn't have cvmfs. I did install Singularity here already. So that's just a DNF install, yada yada. It's actually in the slides what you have to do. And if I just copy paste this, it should, yeah, the container is already cached, so I tested it this morning, of course. It drops me in a shell in the container, and here I have cvmfs available and the EESSI repository mounted. So here you can source the init script and start playing single node. That's fine. As long as you have Singularity on the system, it should work fine. So that's one way if you want people to play around with it. Just tell them these instructions, or put this in the script and say run this, and it will drop you in an environment that you can play around in. So that's very, very easy to play with. That's certainly good enough single node. If you don't want to talk to your sysadmins to get them to install cvmfs and you have Singularity on the cluster, you can use this anywhere. The more serious option is a native cvmfs installation. Now, what we explain is just the very basics of it. Installing cvmfs, which is trivial, installing our EESSI configuration, for which we have RPMs and Debian files, and if not, you can, I think, just unpack a tarball and put the files in the wrong place. And we create a very minimal configuration file which just tells cvmfs basically how big the local cache is. So can it use 1 gig, 10 gigs, whatever. So you can play with this. So that's good enough to get native access. But it's not the proper setup, certainly not for production use on a big HPC cluster, because again, as soon as worker nodes start using the EESSI repository, they will be hammering our Stratum 1s, and they will be serving all that data to get the software working. There's a local client cache, so if you do it again on the same worker node, it will stay there. If you burn down the job, then probably gets cleaned up. You'll lose the cache, you'll have to do it again. So it's very easy to bring our Stratum 1s to its knees with your HPC cluster. So be a bit careful if you use a setup like this. For now, I guess it's okay since it's a pilot repository, and if it goes down, nobody should scream. But yeah. So a real proper production setup would be to have a squid proxy in your network that acts as a local cache for your site. So anything that gets downloaded from the Stratum 1 lands in the squid proxy cache. And then if a worker node asks it again, it gets pulled from your cache and not the Stratum 1. So you get like a middleman thing. That's a partial cache. It will give you also better startup performance in your cluster, so that helps. But it's partial, it's not a full mirror, it won't have everything. So it will still, if your cache is not big enough, have to talk to the Stratum once again. If you want to prevent that from happening, you can set up your own Stratum 1 mirror, have a full copy of the full EESSI repository. Right now, that's maybe, I don't know, 50 gigabytes, 100 gigabytes, if it's even that. So it's quite small. And this protects you also from network problems. If you lose a connection with the outside internet for God knows what reason, the Stratum 1 is in your network and your cluster can keep going. So, and that's actually a very important point. If you're using CVMFS as a software stack for your users, and that's the only software stack you have on the system, it becomes a pretty critical component. And you better make sure that you have a proper CVMFS setup. Otherwise, if you lose connection to the internet, you'll have an empty cluster. And that's probably not what you want. Now, there's other steps you can take to protect yourself from this. You can, for example, have an NFS export of a CVMFS mount. So if you don't want CVMFS on your worker nodes at all, we just do an rsync, a continuous rsync, and there's ways around that if you want to protect yourself. But yeah, a proper setup, squid proxy, maybe your own Stratum 1 is also being nice to us, but not hammering our Stratum 1s. Now, the very basic of that, without the squid proxy, without your own Stratum 1, this is all you need to do. So you pull in the CVMFS release RPM, which just tells the system what the latest version of CVMFS is, and then you can do a DNF install CVMFS. It will pull down the latest version. You can download and install our CVMFS configuration package, which is, I think, essentially 1 or 2 files. It's like the public key that corresponds to our repository, and it tells CVMFS that EESSI exists, essentially. These 2 lines are just creating the etc CVMFS default.local, which the first one says, I forgot what this means, client profile single. It means something that's there for a reason. I don't remember the detail. The second one is maybe the more important one. That's the size of your cache in megabytes. Yeah. Cool. Sorry? The first one is for the... Okay, yeah, has to do with the squid. So single means there's no squid? Yeah, yeah. Yeah, that's possible, yeah. So this is actually where you're admitting I'm not a proper citizen in the network. Yeah, I'm just going to talk directly to Stratum 1.
That's something what the CERN packages also use. It's indeed that you're intending to use this as a single client, and then automatically it will set the proxy to direct instead of using a squid proxy.
Right, okay. So it is indeed bypassing or not using a proxy deliberately because you say, I'm just testing and playing around. Yeah, okay. Yeah, that's all you need to do. Install CVMFS, install the configuration, create that configuration file. You run CVMFS config setup. I'm not actually sure this is needed, but if you do, and something is horribly wrong, it will probably tell you. And then you're good to go, EESSI is mounted, and you can start running it on your system. So as long as you do this on all the worker nodes, tada, you have a bunch of software that you can. Now this is all for RHEL 8, of course. There's equivalents to this for the Ubuntu. So CVMFS has pre-built packages. And again, for production setup, this is not enough. If you want to learn more about a more proper setup, so how do you set up a squid proxy? How do you set up your own Stratum 1 and mirror something that exists? Bob and I actually puzzled together a tutorial on CVMFS while we were learning CVMFS ourselves. And we presented this at the last CVMFS workshop last year, fully virtual. We figured, okay, let's try to connect with that community a bit and also learn something while we go, and that was actually pretty well received. But I think it's a good tutorial with lots of hands-on as well. It also creates your own software repository, your own Stratum 1, then a Stratum 0, sorry, a Stratum 1 that mirrors that, a squid proxy in front of that Stratum 1, so it gives you the whole experience from 0 to setting up a CVMFS network. And of course, for EESSI, you only have to do part of that squid proxy and maybe your own. Then option 3, and the developer of CVMFS exec was at the CERN VM workshop yesterday and the day before here in Amsterdam as well. He has reminded me 2 or 3 times that CVMFS exec exists, that I should try it. Still haven't done it, but as a middle ground, I made a slide on it as well, so you can try it. So if you check the CVMFS exec GitHub repository, it has different modes, but one of the modes it supports is fully unprivileged mounting of CVMFS repositories without having CVMFS on the system. So a normal user can, on a modern OS, that's an important important side note. So on RHEL 8, it should work. RHEL 8 means you have user namespaces. Users can do pretty nice stuff. If you have that supported, CVMFS works fully unprivileged. You don't need a container. You don't need CVMFS on the system. You can mount any CVMFS repository and just go. Now again, multi-node probably a bit more complex than that. So, or at least you have to be a bit careful. But certainly single node, this should work just fine without using our container and the tricky singularity command line option. So I haven't tried this myself, but it should work. If it doesn't work, we can complain to this guy. He said it should. All right. Yeah, so that was a lot of talking, but now also, and now I'm already leaking into the post coffee break. So we have half an hour planned after the coffee break, which is about to start. So in the next hour, if you want to, you can play with this. We can give you a VM in AWS to play with, where you get sudo rights. We will burn the VM at the end of the day, or if you want to keep it until the end of the week, probably okay. So let us know in Slack in the community meeting 2022 channel if you want a VM to play with, and then either me or Terje or maybe Bob, if he's still around, can help you. We will either link it to your GitHub account, or we will drop your pub key in there and make sure you have sudo rights, and you can. All three options should work there. You can try with the client container, try via Singularity. You'll have to install Singularity first. You can just copy paste these commands. It's a RHEL 8 VM. You can just download the latest version of Singularity, the RPM that's pre-built. That's the current one. I checked that this morning. So just download that and do a DNF install on that, and you'll have Singularity. That's enough for option 1. For option 2, you can just use the commands from the slide. Install CVMFS, install the configuration, create the default.local file, and do the mount. And if you want to play around with CVMFS exec, you can try that as well. No idea if it works or how difficult it is. It should be easy to work as well. So if you're up for that, please play around and just shout if you need any help or if something. Yeah, that's it. Slides are also available on the website, so to copy paste the commands, you can just grab them there. Okay. So we're good on time. Any questions before we start the coffee break? Or remote, maybe?
Regarding the installation of the Stratum 1 mirror on site, are we allowed to inject stuff into the mirror?
Oh.
It should be
no,
just
the mirror is pulling stuff from Stratum 0, thinking with that, but it's one way. You cannot go the other way. So Stratum 0 is the only place where you can add stuff. The repository.
Because at least with certain VMF, you can actually add stuff to it.
Not on Stratum 1. Or well, I don't know what you can do there, but it's not going to go to the network.
Yeah, but that's the point. So the idea is to have something that is local to our site. Only available to our site.
But what you then should do is set up another CVMFS repository next to each.
Okay.
Have your own Stratum 0 that hosts that. And there you can get write access to your repository, not to ours. Yeah.
Because I'm actually thinking.
And then mount that as well next to it, and it sits on top of EESSI. That's what you can do. Or it doesn't have to be CVMFS. It can be NFS on top of CVMFS.
Okay.
It can be local install on top of CVMFS. You can use the libraries from EESSI and have your own binaries that link to those.
Okay. Yeah. Because I'm actually thinking about something simpler, like what if I want to do some module of some of the software that is available to EESSI? What if I need to customize some environment variable, something simple that we do in the module itself? Then I would like to have my own module for the software in EESSI.
Yeah,
but
you could have a module that shadows ours. So just that's early in the module part, and that's all you really need to do. But what we also want to do is open it up to the community. So it's not like 5 people are going to build EESSI. we want the community to build easy. We're going to set something up that you can send us a pull request and say, I want to use this easy config file and maybe this update to the easy build hooks because I'm not happy with what the easy build does, or what easy build does by default is not enough for easy. That's possible. Send us a pull request, and we're going to have a bot that tries to build that, test that, and if one of the admins of easy pushes the button, the bot is going to deploy it into easy. We're going to automate that as much as possible.
Yeah, because that will take time.
And yeah, it will take time and effort, and we have not building for one CPU, we're building for a dozen CPUs. If it's not automated, it's not happening. And that's why right now we have OpenFOAM, TensorFlow, a bunch of software packages there, but those were essentially built manually. So figuring out how easy build needs to be configured, having a script for that. It works fine. We make a tarball, we drop it on Stratum 1, but that's just the human moving all of that around. We need to get rid of that first. Once that's automated, we will blow up the software stack to anything that easy builds, because then everything is automated.